let's work this little problem where we're calculating the volume of 1 mole of a gas at 0 C, which is 273 K, and 1 atmosphere. And if we plug in those numbers, what we get for the volume is 22.4 liters, and that is rounded to 3 sig figs. So notice that I didn't have to tell you which gas it was. We would get the same answer if it were hydrogen or helium or oxygen or whatever, as long as the gas obeys the ideal gas law, as long as those assumptions were reasonable. So for any ideal gas, 22.4 liters for a mole. And so this makes a helpful conversion factor sometimes when we're dealing with gases to just kind of assume standard conditions. We call this STP. And by the way, so sometimes we say it standard conditions. That means STP, standard temperature and pressure. And you need to know standard temperature is 0 C and standard pressure is 1 atmosphere. Okay, and this comes out of Avogadro's law, that if we're at the same temperature and pressure, then equal volumes have equal numbers of particles. So let's look at how we can use that. We're going to connect that to stoichiometry. So right here, where I was talking about 1 mole is 22.4 liters, that's going to be a conversion for a gas at STP. Okay, so this part right here, you know what? We have another way, though, to go between moles of a gas and volume. If it's not at standard temperature and pressure, you could also just use PIV-NERT. I say PIV-NERT a lot. I learned it that way, kind of instead of saying the ideal gas law. Anyway, so that's 2 ways to get between moles and volume. And then like I said, we're going to connect that to what we already know about stoichiometry. And let's just go over here where we're talking about moles and grams. How do we get between moles and grams? Well, we're going to use the molar mass of that gas, which is A. And here we could do the same thing. We could use the molar mass of gas B. And if we have a chemical reaction, we can go between moles of one substance and moles of another, any other substance, using the coefficients. And then lastly, over here, there's a conversion we can do where we could go between moles of B, or moles of something, and molecules. And when I say molecules here, I'm talking about number of molecules. And whenever you think about number of molecules in chemistry, you should be thinking about Avogadro's number. Molecules per mole.